The washer method is different than the disk in that the shape is not attached to the axis of revolution the whole time, so there may be a little gap either the whole way through or part of the way through. And what happens when you revolve that shape around the axis of revolution, you end up with a hole in the middle, and so it requires a little bit extra to figure that out. What we're going to do for volume is we're still going to use pi r squared, but instead of r has to be, indicating that there's a hole in the middle. So we're going to find it like there wasn't a hole. We're going to find the big R, which is the big distance from the axis of revolution to the outer edge. And then what we're going to do is take and find the inner radius, which would be the distance from the line of revolution to the inner edge, and that part is going to be the extra. And so we're going to basically find the volume with that purple function, find that whole thing like there wasn't a hole, and then we're going to subtract out the hole, and the result will be the volume of the washer. So my complicated R this time is capital R of X squared minus small r of X. And you can see how I have those labeled there. It's dx if we are revolving around a horizontal line, and it would be from A to B. So let's try one. Here is my, kind of flower petal shape. If I revolve it around the x-axis, I end up with this bowl with kind of this bubbled shape and a big, space in the middle. So it's a washer. It's a washer because there's some space here between the axis of revolution and the shape. So even though it's attached here, there's some space here. So this is a washer method. When I find the volume, I'm going to start with pi, and I look at my bounds. I'm going to go from, because it's horizontal axis of revolution, I'm going to go around the x-axis, starting at 0, ending at 1. So that's my bounds. My capital R, which is my large radius, that would be the distance from the axis of revolution all the way to the outer edge. And you see that here, it's this distance. That would be my first radius squared that I have to do. So it's going to be whatever this function is, and it looks like it's square root of x, so it's going to be square root of x squared. That is my first radius squared. If there was no gap, I'd be done, but there is a gap. So then I have to go minus this little distance. This is like axis of revolution to the closer side. So it would be, the equation for that is x squared, and then, like I said, it's going to be, radius squared. So there's my radius squared, here's my radius squared. I subtract those, and I'm left with just the shape. It's dx because I'm revolving around the horizontal axis, and this is good to go. I can now evaluate. So volume is pi from 0 to 1 of square root and squared cancel, so that's x minus x to the 4th, and I'll integrate. So x squared over 2 minus x to the 5th over 5. I'll plug in 1. I'll plug in 0. If I plug in 1, I get half minus a 5th. If I plug in 0, I get 0. And so if I get a common denominator and figure out those constants, I would get 3/10. So it's 3 pi over 10 is the volume of that solid of revolution.